Just to confuse students, this is being brought. Let me proceed with the set of diagrams. Okay, there's a sun. Sun will be far away. Actually, it's a spherical. The diagram, plane diagram will appear like this. There's a sun whose diameter has to be. I do have a lens. Okay, these two are the lens, objective lens, and there's the eyepiece lens. And the final image is given from the objective. You obtains an image of sun on a screen 40 centimeter behind the eyepiece. This is the FE. This is F naught. A little bit, you be careful the way he has made this question. Okay, this is the final image. I2 is final image. Do we know FE? Yes, we know. So from that, I think we can get UE. And this should be the F naught or V naught. If you're getting confusion, you write V naught where that V naught is F naught. And as usual, we know this should be the alpha. This should be the alpha, and there's a distance x. What is our question? What is the estimate of the sun size given that average sun distance? He's asking the small d only. That is the only thing that is being asked here. Let's take help of our ray optics. What we know, this is what VE. We should call this as like a VE, and which is VE is equal to how much? 40 centimeter. And we know FE, eyepiece of focal length, 10 centimeter. Let me apply the ray optics method. 1 by VE plus 40. This UE we don't know. Okay, let it be. And this is plus 10. UE will be minus, or don't put sign. What do you mean by negative? It will be this one. So this will be this image I1 will become object for this one. So that is what UE we got it. Okay, now you know UE. So what is the magnification produced by the eyepiece? You see that I'll proceed in this way. ME equal to VE by UE. VE we know 40, and this is Magnification is 3. So what is the diameter of the image? So this is what I'll write D1. So can we say anything about D1? The diameter of the sun's image is measured to be 6 centimeter. What is the 6 centimeter? Where the 6 centimeter is this one? Huh? How you define magnification? Okay. Yeah, fine. Yeah. So how you define magnification? Height of D2 by ME is equal to D2 by D1. So I know D2, I know ME, I'll get the D1. Okay, now I know D1. So what is I1? Image formed by objective. Okay, let's take help of the triangle. So looking at the triangle, tan alpha. So this will be D by X is equal to D1 by X. So they were D is equal. They should be V naught, no? And we know V naught should be equal to F naught. So this will be D1X by V naught. (1.5 into 10 to the power of 9 meters). So these are the types of numericals what you can expect. Diameter of the, not image, image formed by objective, this final image form on the screen. So a student must have, see like now optical instruments are, I know formula. You see, is that formula applicable? What all we have magnifying power, you see, may not be applicable in this case. That's why I'm suggesting you like, not mere reading theory will not help you. You have to explore some numericals so that you'll get a picture. Oh, this is what happening. Now, the moment astronomical telescope means you can't just use formula F M equal to F naught by Fe, M is equal to F naught by Fe 1 plus D by Fe. They may not help you here. Especially heavenly objects, it is view, no, this angle alpha will come into picture. Do remember. Telescope telescope, okay. Earlier also I shown you a few problems. Not just formula based questions may not, they may not confine, they may ask you questions of these kind also. As a teacher, my duty to inform you, you have to think over like this also. You open the material or most of the books now, we have everything formula of that magnifying power straight away, but they may ask you questions of like this. Just be alert. Okay, after this, there's about the astronomical terrestrial telescope. What is the terrestrial telescope? Again, it's nothing but astronomical telescope only. Only one inverting lens will be there. I think I discussed long back. All of you, if you can, shall I just put diagram once, or if you know it, okay, I'll skip this one. Terrestrial telescope. Shall I discuss that? Only length of the astronomical terrestrial telescope will be different. Here, one inverting lens will be brought here. Shall I discuss terrestrial telescope, or shall I skip? Choice is yours.
No need, sir.
No need, no need. Reflecting telescope. Till now they didn't ask reflecting telescope, the formula in the rough diagram.
It's a reflecting telescope. Can you explain?
I'll explain once. Reflecting telescope. Okay, what is the problem with the astronomical telescope is like, whenever a light passes through a lens, objective lens, some light will be absorbed by it. Okay, got this one. And moreover, objective what happen, its size should be same more, no? So why do we go for more aperture? To increase the resolving power. I think there's a very important part of the resolving power. How to improve the